Hi everyone, Pong here from Roll Robotics. Today, I want to share with you a case study on robot operation for pick and place process. We will be looking into some problem statements, challenges faced, what we did to make the process works, and lastly, a few key takeaways from this project. Before I continue, a quick introduction to who Roll Robotics is. Roll Robotics was founded in 2019 as an industrial robot development company. We then expanded our business portfolio by becoming the official partner of Visual Components in 2020. Currently, we have two offices, one in Malaysia, which is the headquarters, and another one in Thailand. Our focus market is in Malaysia, Singapore, Thailand, and recently, we have broadened to Indonesia. As the partner, we introduce and promote visual components to potential customers and also provide simulation services. Supports are part of our services too to help our client in learning and solving simulation issues in visual components. Alright, back to our case study. Let me give you some background of the project first. Roll Robotics was introducing visual components in Malaysia market, and MODU System, a system integrator based in Malaysia, was interested in the 3D engineering too. Roll Robotics was given an opportunity to do a simple demo for their automation solution. MODU was happy with the result and now became a visual components user. At the same time, MODU was proposing an automation solution to a public listed food and beverage company. Their automation solution is meant for their South Africa plant during global lockdown in 2021. During the proof of concept finalizing phase, the end customer wanted to see maximum production capacity and higher robot usage. Roll Robotics was once again engaged to do further study on the solution to make suitable improvements and optimization. To start the project, we had formulated some objectives to achieve our end goal. First, we want to minimize on-site travel for MODU as there is a global lockdown and travels are restricted. A simulation came in helpful for them to study and analyze their automation solution. The simulation aims to determine the suitable number of SCARA robots required to fulfill all conditions requested by the end customer. At the same time, we also optimize and improve the automation process as we analyze the simulation. When doing studies on the automation solution, a few requirements from the end customer were needed to be met to ensure high production capacity of their plant. The first requirement is to make sure the line capacity reaches 180 cans per minute to meet the demand for the product. To achieve that, the production line needs a constant flow of products. Third is to ensure a high robot utilization rate. This is to prove that the solution is worth the investment. Last but not least, the end customer emphasized zero wastage during the robot operation to prevent additional work in the process. Before we go into the solution, there are some main challenges faced in this project. One of the challenges is to set a suitable speed for the conveyors, as you can see in the image here. The conveyor speeds are crucial to achieve the line capacity and zero wastage. Other than that, the robot algorithm to carry out the pick and place operation is also important as there are many methods to achieve it. Initially, the production line is running at a line capacity of 170 cans per minute with a constant conveyor speed of 250 mm per second. This was not the ideal result, so some methods are applied to meet the end customer's requirements. Throughout the project, we worked closely with MODU project designer for this project to get the necessary data, information and materials so that setting up the simulation will be a smooth process. We started off by configuring all SCARA robots to carry out the pick and place process properly. We study and compare different algorithms for the robot programming to achieve high utilization rate. The only issue left was that the spoon timing was not ideal, resulting a delayed pick and place process and reduced line capacity. So, in order to fix this, we try to optimize the conveyor speed for the spoon product. For the can product conveyor, the speed is set constant to make sure that the can supply in the production line is met with the line capacity proposed. As a result, the production line was able to reach 180 can per minute line capacity with 4 SCARA robots. Then, we realized there were a lot of spoons that were not picked up by the robots. We were looking at about 1,000 spoon wastage in a short 30 minutes. Hence, this condition is not acceptable at all. After a discussion with module project designer, we came up with a solution by implementing a conveyor speed control method. The speed was controlled by the robot to slow down the conveyor when it had picked up and speed up when it needs to pick up. From this solution, the line capacity is not affected and there is no wastage of the spoon product. Next, the end customer wanted to go for a higher line capacity of 280 can per minute with 5 SCARA robots. The robots are separated into 2 lines due to space constraints. The same conveyor speed control method was also applied to this new layout, but the suitable controlling speeds for the spoon conveyor are more difficult to adjust. As a result, the new layout concept is still managed to achieve 280 can per minute, but with a 6 unpicked spoon count that only occurs at the start of production. Let's watch some videos to have a better understanding of the simulations. On the left side is the initial design concept for the automation solution with 4 SCARA robots. The process is to transfer spoons from one conveyor line to the can on another conveyor line. If you notice, all robots are assigned to transfer a specific sequence of spoons to their targeted cans. This is to ensure all robots are being fully utilized. Also, you could see the spoon conveyor slow down and speed up according to the robot's needs. On the other hand, using 5 SCARA robots requires a new layout design. The robot arrangement is separated into 2 sections to cope with the limited space. However, the process is the same as the 4 SCARA robot layout. Through visual components, we collected some data about production rate and number of wastage. For the 4 SCARA robot layout, it managed to reach 181 can per minute, higher than the proposed target. There is no wastage with this configuration as all spoons will be transferred. The 5 SCARA robot layout also managed to achieve 280 can per minute with the solutions applied. But it has a wastage of 6 spoons that are not picked up by the robot due to the timing. This small issue is acceptable as it only happens during the start of production, so it can be considered in the warm-up time of the production line. In the end, Module is satisfied with the outcome of the simulations to proceed on their end for the physical system and discussion with the end customer. Before we conclude our discussion, we'd like to highlight some key takeaways from the case study to everyone. One of the biggest benefits that Module has seen from visual component is that it helps them in making critical decisions. Through simulations, Module managed to decide on the suitable conveyor speeds for spoon products to meet robot operation timing. They were also able to determine the suitable number of SCARA robots, which highly affects the line capacity. We had helped Module to set up a suitable robot algorithm to meet the high line capacity. With this information, Module can make a better decision on their solution to meet their clients' requirements. As the simulation is done in-house, it also helps Module to save time and travel costs for the project. A physical mock-up test has now become not as important in the early stage in comparison to how it used to be, because we had done studying robot algorithms in visual components for them to understand the configuration and parameters required for the process. By using visual components, studying robot algorithms and behaviors can be done easier than setting up physical robots. This saves Module time and cost during the real commissioning of the project. Finally, visual component simulations provides better visualizations to Module and their clients, as the simulation is done through a 3D virtual environment. By looking at the 3D models and simulation videos, Module can see how their automation solution will operate practically. Adding on, with 3D simulation, Module had a better view of the whole layout for improvements and optimizations compared to a traditional 2D floor plan. With that, our case study comes to an end. We would like to take this opportunity to thank Module for allowing us to work on this project together. We really enjoyed the process of creating this simulation. If you also enjoyed the case study, don't forget to subscribe to our channel to know more about 3D simulations with visual components.